Hello learners, welcome back again for this digital electronics laboratory. The aim of the laboratory is or aim of this experiment is to analyze the circuit and truth table of 4-bit serial in parallel out shift register by using IC 7474, that is the D kind of flip-flop. So this is the experiment number 10 in your syllabus, design of shift register. So this is a special one kind of shift register, that is serial in parallel out, where we have a shift register in which data is coming serially, but output we are taking parallelly. So let us see, this is the aim, and again this is from Digital Electronics Laboratory from IIT Roorkee. Let us see theory. So serial in parallel out shift register, the data is stored into the register. Register is a group of flip-flop which stores binary information, while it is retrieved from it in parallel fashion. So SIPO is nothing but serial in parallel out shift register. So figure 1 shows an n-bit synchronous SIPO shift register sensitive to positive edge of the clock pulse. Means whenever there is a rising pulse, then only there is a change in the state of these flip-flops. Here the data word which is to be stored, that is data in, is fed serially at the input of the first flip-flop. D1 of this is here first flip-flop, leftmost side. It is also seen that input of all flip-flop except the first flip-flop F are driven by the output of the preceding one, like the input of F2. So here you can see the input of F2, that is flip-flop 2, that is D2, is received the output from flip-flop 1, Q1, and so on. So that is why it is a cascaded form. In this kind of shift register, the data stored within the register is obtained as a parallel output data word. We can take the output parallelly, like Q1, Q2, Qn. So data output is mentioned here, and data input shown from the this green color. And common clock is given to all flip-flops, and a clear pin is given in order to reset. So in general, the register contents are cleared by applying high on the clear pin of the flip-flop at initial stage. After this, the first bit B1 of input data word is fed at the D1 of. Okay, let us see how this from the table we can see. So Q1, Q2 to Qn, these are the outputs, and these are the data in which is mentioned here, B1, B2, B3. This is coming serially. It is a train of input pulses. And this is the clock cycle. We have given here number 1, 2, 3, 4, 5, 6. So you can see here, figure 2, this is the clock on every rising pulse, which is shown red color arrow up. So 1 clock, 2nd clock, 3rd clock, 4th clock, and so on. And here the states of the Q flip-flops, that is the Q1, Q2, and Qn. And this is again. So let us see how it works. So before that, let us attempt that pre-test. So a register that can be used to provide data movement is called shift register, that is the D option. And n-bit register has a group of n number of flip-flops and some logic gates. Shifting a register content to left by one position is equivalent to, because see, weight increases towards left side and decreases right side. So if and in binary number 2 to power 0, 2 to power 1, 2 to power 2, so if we shift from left to right, then what is going on? There is a multiplication of 2 factor. That is my option C. To serially shift a nibble is called group of 4-bit. It's called nibble of data into a shift register. There must be 4 clocks pulses in order to shift all data. This all data of 4-bit. What is meant by parallel load of a shift register? Means we are giving parallelly. So all flip-flops are preset with data. So let us see. So all answer are here correct. Let us move to next. Sorry. So this is the procedure which is given. So you have to first connect the power supply, then keep the reset and preset as high in order to inactive mode. Apply the data as data input, then press the clock pulse and observe this data at LED Q3, then press add button to add data in the given truth table. Apply the next data at the input, press clock pulse. Let us see how we can do simulation. So initially I will take the data 1011. So as per instruction, this is the circuit. You can see there are 4 flip-flops cascaded together. This IC is 7474, which contains 2 D flip-flop. So D flip-flop left hand side and right hand side. So in each IC there are two D flip-flops. So in order to make 4-bit, we need 2 such ICs, so that 4 D kind of flip-flop is available. And here we follow this VCC is connected to pin number 7, ground is connected to pin number, sorry, VCC is connected to pin number 14, and ground is connected to pin number 7. And here reset, then D input D1, then clock, then preset, then clock C. This is again D. What is here? Yeah, Q. This is the output Q1. Pin number 5. Pin number 6 is Q bar. The 7. Okay, so we can see this diagram. And after that, let us see this. I want to connect this power supply to the 4 flip-flops. So it is connected here. We have to just click here. After that, this is the data in. We have to input the data serially. So we decided that 1011, that data I will give. And reset and preset both are high. Initially, these values are 0, 0. And I apply here clock. This is clock pulse. And Q3, Q2, Q1, and Q0. These are the 4 outputs. So this is Q0 is the least significant bit, and Q3 is the most significant bit. After that, suppose I have given here red is the data 0. So let us assume that all data is 0, 0. So in the table, we see serial number 1, clock is 0, and data is 0. So all outputs are 0, 0, 0, 0. So this is the first. So I want to insert this data 1011. So 1011 data will be there. So in further 4 clock cycle, this data will be entered. So now as I want to put 1011. So first right mode bit is 1. I will give here 1 and rest are 0, 0. Apply the clock, then put the, you can see after application of clock, this data is 1. 1 data has come at Q3 and rest are still 0. And now this entry, the output of this these flip-flops are entered into the truth table by adding. So you can see this clock has come here 1, and data is 1, Q3 is 1, and rest are 0, 0. Now after that again 1 I want to put. So I'm not changing. So this again 1 clock, and you see this 1 which was available at Q3 shifted to Q2, and then Q2 was having 0, which is shifted to Q1, and Q1 was having 0, it shifted to Q0. Q3 has entered 1 because we are giving the input 1, and this is the what is the data is mentioned here. And after that I want to put here 0. So data is 0, next clock pulse. So you can see Q3 become now 0, Q2 is 1, Q1 is 1, Q0 is 0. And add this value in the truth table. And after that 1 is there. So I will give 1, next clock pulse. So you can see here this is 1 because I have given 1 data Q3, and earlier it was 0, so 0 shifted here, and 1 was here, so 1 is coming here, and 1 was here, 1 is coming here. let us add this value. So at the clock 4, data 1, so you see 1011 data has come. So you can see the data input is this one. Okay, so this data then 1. So 1011 data has come after 4 clock. So in this way, we can shift the data into serial in, parallel out. And you can do furthermore whatever input you want to give. Now let us see, this is the instruction you can read before doing the experiment, and you can print this circuit as well as to table by pressing on print. You can see it will come here. So this is the truth table as well as the circuit diagram. Then coming to next, once we have done, let us attempt for post test. So based on how many information, how many binary information is entered or shifted out, shift register are classified into how many categories. So see, there are 4 categories: serial in, parallel out, serial in, serial out, parallel in, serial out, parallel in, parallel out. So there are 4 categories. So I will put here 4. Then how can parallel data be taken out of a shift register simultaneously? So by taking use of Q output of each flip-flop. So D option. So use of Q output of the first, no, it will give only one output, not parallel all. Use the Q output of the last, no. Tie all output, no. Use the Q output of each flip-flop. Now again, this we have to write basically a group of bits that is 11001 is serially shifted, means right mode means first is shifted, right most. So let us write this data 11001. This is the data which is entering into the SIPO into a 5-bit parallel output shift register with the initial state. So what is the initial state? Initial state is 0, 1, 1, 1, 0. After 3 clock pulse, right, the register contains. So we have to count 3 clock pulses. So first clock pulse, if it is coming, so what will happen? This first bit will enter. This one, first bit will enter at the Q4. Then 0 will shifted here, 1 will shifted here, 1 will here, 1 will here, and 0, last 0 will be discarded. In second clock pulse, this bit will this bit 0 bit will come. So 0 is coming here, 1 is here, 0 is here, 1 is here, 1 is here, and last one will go. And third one, your 0 bit entered, 0 is coming here, 1 is here, 0 is here, 1 is here. So 0, 0, 1, 0, 1. 0, 0, 1, 0, 1 will be the output. So here 2 are there. So 0, 0, 1, 1. I will prefer to do this one. 0, 0, 1, 0, 1. Now the full form of SIPO is serial in, parallel out. A shift register that will accept a parallel input or bidirectional serial load and internal shifts feature is called universal shift register that we have done in our theory classes. So let us submit the quiz, and after that some references are there. You can read this, and you should give this feedback also. What is the So in this way we are able to design a 4-bit serial in, parallel out shift register. Sufficient theories are given here, and then pre-test you can attempt. Procedure is mentioned here. Then for simulation, the circuit is given. You have to connect first battery, and after that queue the data serially. Please predetermine some data, whatever data you want to insert, and then note down how this data is shifted on pressing each clock pulse. So thank you so much for attending this laboratory. See you soon.